For this example, we want to graph r equals 2. So this is a polar equation. It's just in terms of r. So we want to maybe try and change this into something that we're a little bit more familiar with in rectangular form and can give us a sense of what kind of graph r equals 2 really is. So if you recall back to our last video, we had a few things that we could use to convert between polar coordinates and rectangular coordinates. So we know that r squared is x squared plus y squared. We know that x is equal to r times the cosine of theta. Y is r times the sine of theta. And x divided by y is the tangent of theta. Now, in this case, we just have r. We don't have anything that has to do with theta. So we're not going to use any of these equations here or those conversions there. So we're going to just stick to the equation that only is in terms of r and then its rectangular counterpart. So we want to try and convert r equals 2 into something in this form. So what do we have to do? So r equals 2. Well, I noticed that in this situation we have r squared and here we only have r. So we could multiply both sides by r, but that's going to give us another r in this side, which we don't really have an easy way of converting just an r. So what can I do? I can square both sides. So let's square both sides. We end up with r squared equals 4. And now we can convert, we can use this here and substitute it in for r squared to convert into rectangular form. So we end up with x squared plus y squared equals 4. If you recall, this equation is just the equation of a circle. So this is a circle, and it has a center at the origin, and it has a radius of the square root of 4, which is just 2. So this graph, r equals 2, is just a circle centered at the origin or at the pole and has a radius of 2. So it's going to be just this circle here. Really bad at drawing circles even when I'm trying to trace something. So, but you get the point. It's just this circle here. Now, why is this just a circle? So if you think about it, this is saying that we are basically given points that are 2 units away from the pole, but theta is not defined. So really, this means that for any angle theta, r is 2. So we can really just go out a distance of 2 units for any measure of theta. And if you just started plotting all of these points, you would see that they end up going along this this ring here, and it's just going to form a circle, because we could also hit the points that are in between all of these. Again, remember, theta is not defined strictly. So anytime you see r equals some number, it's going to just be a circle centered at the pole, and then the value that it's equal to is just the radius. Unlike this here, unlike this here where the radius is 4, the value here is just going to be the radius, where the radius here is the square root of this. So this is a circle with radius 2. Again, its equation in rectangular coordinates would be x squared plus y squared equals 4, which is just a circle centered at the origin or the pole, and then with a radius of 2.